Section 8.3, we're going to add one more thing, and that's the middle term. You'll begin to notice that this looks just like a trinomial, which it's supposed to. Right here, we have a trinomial, ax squared plus bx plus c. So what are you going to learn? Well, in this section, you are going to learn how to graph quadratic functions in that form and how to find max and min values of a quadratic function. All right, so now what we are going to do is talk about our core concept. Once again, there are three numbers here, the a, the b, and the c. A is the same as what it's always been. If a is greater than 0, this graph is going to open upward. If it's negative, it's going to flip and it's going to open downward. The y-intercept will always be c. So if I say the y-intercept, you could say 0, comma c, or the ordered pair for the y-intercept. The x-coordinate, and this is the most important. To find the x-coordinate of the vertex, you must do negative b over 2a. Negative b divided by 2a. And that same thing represents the axis of symmetry. The axis of symmetry is x equals that. So for every problem that looks like this, you are going to find the x-coordinate of the vertex and then put an x equals in front to represent the axis of symmetry. Example 1. Finding the axis of symmetry and the vertex. So here it is. Here's our equation. F of x equals 2x squared plus 8x minus 1. Step 1 is finding the value of the vertex and then using that to find the axis of symmetry. So a, in this case, is 2. Now make sure that it's always in standard form here, in ax squared plus bx plus c form, and it is. B equals 8 and c equals negative 1. So the first thing you do is use the formula negative b divided by 2a. I plug in my values. B is 8, so I'd have negative 8 divided by 2 times 2, which would give me negative 8 divided by 4, which would give me negative 2. So right off the bat, we know the axis of symmetry is x equals negative 2. Done. That's the axis of symmetry. And I'm actually going to label that. Axis of symmetry. There we go. Now B. B is the vertex. Now the vertex, you have to have an x-coordinate and a y-coordinate. We found the x-coordinate. It's negative 2. How do you find the y-coordinate? You plug it in. So we take our function, our equation, and all we do is plug in negative 2 for x. That would give me 2 times 4 minus 16 minus 1. That gives me 8 minus 16 minus 1. And that would give me negative 9. So the vertex would be negative 2, negative 9. So how do you graph it? Well, let me show you what not to do. You should not just start plugging in x values and y values and whatever values you want. And the reason we don't do that is because how do I know where it starts? How do I know where it turns? You could make some random t-table and your graph looks like this. Well, that doesn't help me. Does it go down more? Does it turn right here? I don't know. So keep in mind that when you are actually plugging in values, the first thing you have to find is that vertex. I cannot stress this enough. Always find the vertex when you graph this thing. So step 1, find the vertex. So I plug in negative b divided by 2a. Well, b is negative 6, so that would give me negative times a negative 6 divided by 2 times 3. That would give me 6 divided by 6, which means that 1 is the x value of my vertex. So now I plug in 1 to my equation. And if I solve that, that's 1 squared times 3, which is 3 minus 6 plus 5. That's 8 minus 6, which gives me 2. So this is it. This right here is my vertex. That's where you start. So I'm going to graph the vertex 1, 2. So I'm going to put 1, 2. There's my vertex. Now your axis of symmetry. Your axis of symmetry is x equals 1. So we know whatever point I get on one side would have to be symmetric on the other. So actually, I'm just going to color that black here. There's your axis of symmetry. Now, why do I need to find my vertex first? Because I now can plug in values for x. And why is that important? Because this is like my center. I now am going to pick the numbers on the left and numbers on the right. So for example, if I pick, I'm going to pick 1. We know that 1, 2 works. So I'm going to pick the next number smaller than 1. That'd be 0. And then I'm going to pick the number greater than 1, which is 2. This is why it helps when it's symmetric. 0, 1 space to the left, and 2, 1 space to the right. Both of these should give me the same number. So if I plug in 0 here, that's 3 times 0, which is 0, minus 6 times 0, which is 0, plus 5, which is 5. That means if I plug in 0, I get 5. Now if I plug in 2, since it's symmetric, 2 will also give me 5, which does work. So 0, 5, and 2, 5. Now you could go one more and do negative 1 and 3, which will also be the same. But a smooth curve, whoa, that is not a smooth curve. It's hard to draw this on an iPad. So there is my parabola. It should be a smooth curve, and the domain and range. Now, what do you think the domain is? What can the values of x and y be? Well, the domain will be all real numbers. The range is anything greater than or equal to 2. Any real number greater than or equal to 2. That's the lowest value. Everything is above that. So the domain is all real numbers. The range is y is greater than or equal to 2. Now this core concept is super easy. I'm going to ignore all of this up here. Here's what it says. If a is less than 0, that means it's the maximum. It's the highest point on the graph since the graph opens downward. If the coefficient of the x squared term, if a is positive, it opens up, which means the vertex is my minimum. So if it's the highest point, the vertex is my maximum. If it's the lowest point, the vertex is my minimum. Otherwise usually called as max and min points. So example 3, tell whether this function has a min value or a max value. Right off the bat, I see that it's negative 4. That means it's going to look something like this. Therefore, this is going to have a maximum point. So how do you find it? All you do is find the vertex. So the vertex is negative b over 2a. b is negative 24, so if I plug that in, that gives me positive 24. Divided by 2 times a is negative 4, so that gives me 24 divided by negative 8, which gives me negative 3. So we have a maximum. The vertex, my x value is negative 3. Well, I plug in negative 3 for x. So that would give me negative 4 times 9 minus 24 times negative 3. And that would give me plus 72 minus 19, which would give me 17. So the maximum point is -3, 17. So example 4, finding a minimum value. The suspension cables between two towers of the Mackinac Bridge in Michigan form a parabola that could be modeled by y equals and then this really long function, where x and y are both measured in feet. What is the height of the cable above the water at its lowest point? So we want to find somewhere in here the minimum. Well, how do you find the minimum? All you do is plug in your x value, which is -b over 2a. Negative b would be negative, and let's see, b would be negative 0.37 over 2 times a, which is 0.0000098. If you simplify that, you will get approximately 1,888. So that's the x value of your vertex. Now that's not your answer, because if you look here, the water line is how far over you go. How far over is my x value? I don't want that. I want to know how far up. So the lowest point would be your y value. So you plug that back in. So now this is where you just use a calculator. You plug it back in, square it, times that, plug it in for there. If you do plug it in, you get a value of about 203 feet. So my answer would be approximately 203 feet above the water is the lowest point of that cable. All right, so now we have a rocket balloon or a water balloon launcher. So here's our water balloon launcher. We're going to launch it. It's going to form a parabola on the way down. So here's our problem. A group of friends is launching water balloons. The function, which is given here, represents the height in feet of the first water balloon t seconds after it is launched. So this is water balloon 1. The height of the second water balloon t seconds after it is launched is shown in the graph. Which water balloon went higher? Now you could use -b over 2a and tell me which one went higher. But you can also use your graphing calculator. It doesn't tell you have to graph this. So if you look at the second water balloon, how high does that look? Well, this is 50. It looks like it's going by 25s. So this is a little more than 25. So a little more than 125. So you could say maybe 130 maybe? So now you can graph the other one on your graphing calculator. If you graph the other one on your graphing calculator, you're going to get something like this. Now you may have to adjust your window to make this fit, but you'll notice that this one is going to 150, and that means it's counting by 25s. Well, this is 100. This is 125. So this is 125. This one is 125. You will notice that the second one is much higher. So the second water balloon is higher than the first. So on graphs that you can just look at on a graphing calculator or Desmos, you can use those to help you answer a question.